Hi, fourth grade. Welcome to your first day of remote learning for math with Mr. Hansen. Okay, we're going to jump right in today and start with lesson 1 in module 6, which has to do with dividing wholes into equal parts, similar to what we did with fractions, but we're going to use a different system for separating wholes into parts, a system of measurement called the metric system that we're going to learn about today. Our objective for today is to use the metric measurement to model the decomposition of one whole into tenths. Let's take a look at my screen here. Okay, you're going to need a piece of paper. It can be printer paper that's blank. It can be a notebook, whatever works for you. We don't have our whiteboards anymore for math. So if you need to go get paper, pause me and go get it now. Okay, your paper is going to look like mine, just like we would do during class. I'm just going to quickly review what it looks like to separate a whole into parts, okay? This is what we were doing before the break. Remember tape diagrams? Everybody should be drawing. Your paper should look like mine. Draw yourself a tape diagram. We're going to separate our tape diagram into tenths. Start by separating it in half and then separate each half into fifths so that we end up with 10 parts. And remember that if you want 10 equal parts in a tape diagram, you're only going to draw 9 lines. Count when you're finished and make sure you have 10 equal or almost equal parts. 1, 2. If you're separating your whole into tenths, don't forget that the way we show our whole is with a bracket at the top. That tells us that each of these parts of our tape diagram are worth less than 1. They are a fraction that is worth less than 1 because our whole is 1, and each of these is an equal part of that whole. When you think back to fractions, you'll remember that the way that we can represent these parts is that each part is equal to 1/10. Label each of your parts 1/10. Together, your 10 equal parts make one whole, and separately, they're each worth 1. This is a 1. 1/10. The way we're going to expand our learning today is to show that we can represent that 1/10 fraction with a system of measurement called the metric system, which uses decimals to represent those 1/10 fractions. If you think back to fractions, you'll remember that we're going to assign each of these parts and our whole a metric value because our objective today is to use the metric system of measurement to represent parts of a whole. So well, without going over all of our metric measurements, we're going to use kilograms today, okay? All we need to know is if we have 1 kilogram here, each of these parts represents 1/10 of a kilogram. These values can also be represented on a number line, right? Tape diagrams and number lines can often be used to represent the same information in 2 different ways. So on the same piece of paper, below your tape diagram, please draw yourself a number line. Make it the same length or close to the same length. And remember that your number line goes on in both directions, even where our writing stops, so be sure to put arrows at each end. Start with your marks, line up with your tape diagram and mark 0 and 10 on your number line, or 0, excuse me, and 1, not 0 and 10. Each increment of your number line can then be added in. And remember, we're copying these lines from above from our tape diagram because our number line and our tape diagram can show the same information. Our number line can now be used to count by tenths between 0 and 1. But instead of writing fractions this time, we're going to compare, or we're going to write our decimal value two different ways, in a fraction and on a decimal. Across the top, we can put our fractions, and in a number line, we start with 0, right? 0 tenths, 1 tenth. We're going to count 2 tenths, 3 tenths, 4 tenths, and if we drew our number line correctly, we should land on 10 tenths. 10 tenths is the same as 1 whole. On the bottom, we're going to write decimal values, okay? So 1 whole is represented as 1.0, 1.0, if we're writing in a decimal value. Tenths are represented this way in decimals. 0.1 is 1 tenth, and that pattern continues. 0.2, 0.3, 0.4, 0.5, 0.6, until you reach 1.0. If you look at this centimeter ruler that is up on our screen now, you can see that this ruler represents 16 centimeters. This edge of the ruler represents 0. Each number represents 1 centimeter. How is this connected to what we are just talking about? You might ask me, well, each centimeter is divided into 10 equal parts, which are called millimeters. Okay, so right now on your paper, you and I are going to do the same thing. We're going to represent 1 centimeter broken down into millimeters. We're not going to draw it so small. We're going to make it a little easier to see and understand, because one of the most important things we should take away from today's lesson is that everything in the metric system is based on tens. Can make calculations very easy to do because each unit of measurement in the metric system relates to another unit of measurement through tenths, right? And what we're looking at now on your screen is that 1 centimeter is composed of 10 millimeters. So let's show that on our paper now with a number line. You can stay on the same piece of paper. You can get a fresh piece of paper. We're going to draw ourselves another number line. And we're talking about centimeters this time. We're going to mark 0 and 1 centimeter. Mark a line that's about in the middle. Draw 4 lines on each side so that the result is that we end up with 10 equal sections. Okay, Mr. Hansen didn't do a great job. This one's too big. Each point on our number line marks 1/10 of a centimeter, which is the same as 1 millimeter. But right now we're going to mark them as tenths of a centimeter with decimal representation. 0.1, 0.2, 1 centimeter can be separated equally into tenths of a centimeter, which are equal to millimeters. Remember that our objective is to use metric measurement to model the decomposition of one whole into tenths. Take a look at your problem set. There's a lot of different ways that we can model one whole separated into tenths. You should be on page 3 of your blue Learn books, your modules 6 and 7 Learn book that we'll be using for the rest of the year. We're going to start with number 2 right now. Let's take a look at number 2. How much liquid is in this container? Okay, this container is our whole. We want to represent the amount of liquid in tenths. That's our objective for today, right? And we want to use the metric system to do so. Well, all of our units are already written in metric. Liters is the metric measurement for liquid. How many liters are in this container? We have 0 tenths, obviously, at the bottom. If the container is empty, it would have 0 tenths liters of liquid in it, right? The container is marked into tenths of a liter. This line at the top here would be 1 liter. That's our whole. What fraction of that whole is shown in this container? We can see 0.5 liters here. This line represents 0.5 liters. So what does our water line, our liquid line there, represent? Hopefully right now you're saying to yourself, that is 6 tenths of a liter. We know that 0.5 is equal to 5 tenths of a liter. One more is going to be 0.6 or 6 tenths. In this section here, we need to show the value as a fraction, not just as a decimal. 6 tenths is our fractional amount. So how many liters are represented here? 0.6 liters, 6 tenths of a liter. This is read as 6 tenths of a liter, and this is read as 6 tenths of a liter. Remember that these values are the same. They're just being represented, one as a fraction and one as a decimal. Numbers 2 and 3, I'm sorry, part 2 and part 3 of number 2 are the same, right? Where are we on our number line? How many liters is represented at that water line? Let's count and solve now. 1, 2, 3, 4, 5 tenths, and we know that because it's labeled. This line is worth 5 tenths of a liter, 0.5. 6, 7, 8, 8 tenths. Show it as a decimal, 0.8 liters, 8 tenths of a liter. Show it as a fraction, 8 tenths of a liter. For the last bottle, shade the last bottle to show the correct amount. The correct amount is given to us in decimal form, 9 tenths of a liter. Show this in fraction form, 9 tenths of a liter. And where will our water line fall on our container? 9 tenths of a liter is 1 away from our whole 1 whole liter. It is 1/10 away. So our liquid line will be right here, 9 tenths of a liter. Okay, let's take a look at page 4. Turn to page 4, please, of your problem set. We're not going to do every problem right now. I want to review a few of the problems that you're going to see on your exit ticket. These problems here are identical to the ones you're going to see on your exit ticket, which is on page 5. Your exit ticket is how you get credit for 2 days' work. You'll submit that to me through Google Classroom. We need to fill in the blank to make the sentence true in fraction form and decimal form. It's an addition sentence. 8/10 of a centimeter plus blank equals 1 centimeter. How many centimeters do we need to add to 8/10 of a centimeter to get to 1 whole centimeter? Now's the time that you can draw a number line if you need to help you. But the question really is, what is the difference between 1 centimeter, our whole, and 8 centimeters, 8/10 of a centimeter, excuse me. What's the difference? 1 centimeter is the same as 10/10. Mark 5/10. And count to 8/10, 6, 7, 8/10. How far is 8/10 from 10/10? 1, 2. Count on your number line. It's 2/10 is the difference. If your whole here is 1 centimeter, which it is in all 3 of these problems, then that is represented in a fraction as 10/10 of a centimeter. So 8/10 plus 2/10 equals 1 centimeter, or 10/10. Notice these decimal equations are the same as the fraction equation they're next to. 8/10 of a centimeter plus 2/10 of a centimeter equals 1 centimeter. Well, 8/10 of a centimeter plus 2/10 of a centimeter equals 1 centimeter. The same values shown 2 different ways. Complete part B and part C now. As you're listening to these videos, if you become stuck or frustrated or don't understand a problem, you obviously can't ask me a question right now during the video. This is the time to circle problems you're stuck on. Write down what your question is. It's going to be hard to remember come small group time, okay? So make note of that kind of stuff now if you can, if you are getting stuck. Okay, this is what you're going to do on your exit ticket. Your exit ticket is exactly the same, just with different values, okay? At the bottom here, again, this is also on your exit ticket. You have to match these 3 different representations of the same values, okay? We have tenths, tenths, and tenths, shown in word form, shown in fraction form, and shown in decimal form. You're just drawing lines to connect them, okay? 3/10, 3/10, and 3/10. 5/10. Where do I see 5/10 as a fraction? 5/10. Where do I see 5/10 as a decimal? 5/10. I'm going to draw my lines to connect them. Okay, it's going to get a little sloppy and a little messy with all those lines, but please connect those values. Show me which ones are equivalent, which ones are equal, okay? Your exit ticket is going to look exactly the same, even with some of the same values shown. So just with what we have on here, you have almost enough information to complete your exit ticket. Okay, 4th grade, we survived. You made it to the end of the first video. Congratulations. Please remember that today's objective was to use metric measurement to model the decomposition of 1 whole into tenths. We can do that with number lines. We can do that with tape diagrams. We can represent those values with fractions, and we can represent those values with decimals. 1/10 can be shown as a fraction. 1/10 can be shown as a decimal. And these units of 10 are the basis for the metric system of measurement that we're going to be spending time talking about as we move towards the rest of the year. If you have questions, please write them down. You're going to get instructions from me on how to submit your exit ticket in your email, so be watching for that. And thanks for making it through my first video. Don't forget to smack that like button. Talk to you soon, guys. Bye.